So let's start the solution to a problem that says solve the modulus of x squared minus 2x plus 2 less than or equal to 5. So we can call this kind of question a quadratic inequality. That is the modulus of quadratic inequality. So the first thing we need to do here is to present the question under consideration. So we are given that the modulus of x squared minus 2x plus 2 is less than or equal to 5. In this case, it means this quadratic expression can be expressed as an inequality to negative and positive 5 in this case. So we are going to actually eliminate the modular sign because the modular sign actually indicates negative and positive expression. So on that note, we now have the breakdown to be x squared minus 2x plus 2 less than or equal to 5 and x squared minus 2x plus 2 less than or equal to minus 5. Now the first thing we need to do here after doing this is to actually transpose to make this equation a standard quadratic inequality. That is making the right side of the inequality to be 0. So which means by transposition we have x squared minus 2x plus 2 minus 5 less than or equal to 3, equal to 0. X squared minus 2x plus 2 plus 5 less than or equal to 0. Now if you simplify that further, we are going to have the next set of inequalities to be x squared minus 2x minus 3 less than or equal to 0, x squared minus 2x plus 7 less than or equal to 0. So at this point, we need to set the quadratic expression to 0 so as to get the critical values which will enable us to solve or to get the solution to that modulus of quadratic inequality. Now doing so, we are going to have x squared minus 2x minus 3 equals to 0, then x squared minus 2x plus 7 equals to 0. So at this point, we have a standard quadratic equation which can be solved using any of the approaches you know for solving quadratic equations. So here, I made use of the quadratic formula, or you call it the Schritt-Arrhenius formula. So, which is said to be x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now we are going to solve this equation simultaneously, as you can see in the presentation there. So we have x. For the first equation, we have x equals to minus 2 plus or minus the square root of minus 2 all squared minus 4 parenthesis 1 parenthesis minus 3 all over 2 times 1. And for the second equation, we also have x equals to minus 2 plus or minus the square root of minus 2 all squared minus 4 parenthesis 1 parenthesis 7 all over 2 times 1. Now if you simplify this further, you are going to have x equals to, for the first one, x equals to 2 plus or minus the square root of 4 plus 12 all over 2. And the second one, we have x equals to 2 plus or minus the square root of 4 minus 28 all over 2. Now simplifying this further, we have x equals to 2 plus or minus the square root of 16 all over 2. Then the second one, we have x equals to 2 plus or minus the square root of minus 24 all over 2. Now looking at the second equation, you can see that we have a negative sign in the root, which can be simplified to become minus, we have x equals to 2 plus or minus the square root of minus 1 times square root of 24. Then you know the square root of minus 1 is an imaginary number. That is, can be represented by small letter I, as you can see presented here. So we have x equals to 2 plus or minus 4 all over 2, and x equals to 2 plus or minus I root 24 all over 2. So at this point, our bone of contention now is to actually focus on the real roots in this case. Now, focusing on the real roots, it means we are going to actually leave the one with the imaginary sign. And that means we're going to take the first one. So taking the first one, we are going to have x equals to 2 plus or minus 4, or x equals to 2 plus 4 all over 2, or 2 minus 4 all over 2. Are you following through? On that note, simplifying that part, we are going to have x equals to 6 over 2, or minus 2 all over 2. Hence, x equals to 3 or minus 1. Now remember, we are actually solving an inequality problem. On that note, we have gotten the critical values to be minus 1 and 3 respectively. Now, since it is a quadratic and the coefficient of the leading power there, which is x squared, the coefficient there is positive, which means we can actually draw a dummy graph. I get what I'm saying now, such that the curve opens up since the coefficient of x squared here is positive. I get what I'm saying now. So doing so, we have that kind of graph in that diagrammatic representation I have for you. On that note, which means that graph, that curve I've actually drawn there signifies x squared minus 2x minus 3. Now, going back to the original question, replacing 0 by y, we are going to have the expression x squared minus 2x minus 3 less than or equal to y, which means that y is greater than or equal to that quadratic expression, which is also the graph we have on that note, which means that if y is greater than or equal to x squared minus 2x minus 3, then you are going to shade above the curve, as you can see it presented here. Now, shading above the curve, it means x, the value of x, or the solution, lies within the curve, as you can see x in that diagram there. The other thing I would like you to take note of is that curve. If you look at that curve very well, you can see that the curve there is drawn with solid line. There is no broken line in that curve, which means that can be done only when you have equal sign in the inequality. Assuming there is no equal sign in the inequality, you don't need to draw the curve with solid line. It will be broken. That is, if you have less than or you have greater than, only the curve will be drawn with broken line. So looking at what we have here, it indicates that x lies within the curve, which means that minus 1 is less than or equal to x, and x is less than or equal to 3, which is the solution to the problem we have here. Don't forget, I still remain your tutor, Prince Obajowo Daniel Nicole, also known as the Mathaholic Arithophysical Biologist. Thanks for listening.